All right. Set 3, Swyk 2. How do I find a least common multiple? So, like, let's say I was looking at something like 8 and 12. What's the least common multiple? So one of the things when I was in school that we would do is we would write out all the prime factors. So here we have the prime factors of 8 are 2 times 2 times 2, and the prime factors of 12 are 2 times 2 times 3. So if we follow my steps that I've written here, step 1, pick one set of factors. It didn't matter which one you picked. So let's say you started with 8, right? So you're building your least common multiple. So you picked 2 times 2 times 2. Then you went to the other factor, or factors, in this case there's only one, and said to yourself, inside of the 12, what does the 12 have that I am missing? Now what I'm hoping you see is that it's missing this 3. Now it's already got 2 2s, so that's not missing, but it doesn't have a 3. Well, this now creates 8 times 3, which is 24. 24 is the smallest common denominator. Now, I understand, folks, that's this made-up problem that's over here, something from when you were growing up or your middle school days, but it's not the same thing as what we're doing at the moment. But that's just the kind of idea. You start with one of them, and then you add factors in from the other one to get the common multiple, which is going to be used in the common denominator idea here in a second. Okay, so let's take a look at what we have here with these numbers. So first we start by factoring. Obviously x minus 4, pretty simple. Can't get any simpler than that. The 5x squared minus 80, it's got a GCF of 5, so the first thing I did was pull out the 5. But then I saw a difference of perfect squares. So I separated it into x minus 4 and x plus 4. Pick one of them to start. So let's suppose that I decide to start with x minus 4. What does the other one have that I'm missing? Well, clearly it's missing a 5, right? I'm definitely missing a 5. I'm also missing an x plus 4. So my GCF is going to be the product of these things. I don't care if you leave your answer like this. Typically, we put the number out in front. I guess I can go glance and look at the answer to see. I'm hoping they don't have you multiply that together because that'd be stupid in my opinion. Waste of time. Okay, I'm good. It's exactly like what you see down there. You don't have to multiply it together. All right, next. We want to add things together. In order to add things together, we have to have common denominators. This particular one already has common denominators. That's cool. So therefore, I don't have to mess with finding common denominators. I can just add the numerators together. Now, when you add the numerators together, you are going to add like terms. So you're really adding the 8w and the 3w. That'd be 11w. And the plus 1 and plus 1 is plus 2. So that's it. That's your answer. They're going to ask you about restrictions again. Look at the denominator, right? W cannot be equal to 3. I'm sure you're just going to have to put a 3 in the box, you know, because your real answer will go here, and you'll put a 3 in the box, you know, good old stuff like that. Next question. Also has the same denominator, right? 2y. So we add the numerators together. 1 plus 1 is 2. This one, however, simplifies, right? 2 divided by 2 is 1. Therefore, we have the answer 1 over y. And remember, when you set the denominator, the factors in the denominator not equal to 0 and solve, that's your restriction. We couldn't put a 1 in here if we wanted, or a 0 in there if we wanted to. That would have caused a huge problem. Question 12. So you can see the first thing I did was I factored the denominators there. I got the x times x minus 9 and the 9 times x minus 9. So start with one of them, let's say we start with the one on the left and we say, what does the other one have that I'm missing? Looks like it's missing a 9. Now, you could go further and you could say 3 times 3, because in some situations that would really actually be necessary. But in this case, it was missing both 3s, so that's a total of 9. So I decided to multiply the top and the bottom by 9. Okay, but the other one, it's missing another x. So I multiply the top and the bottom by x. Okay, so we have 81 on the top, and now watch this. Don't forget that the minus goes with the x times x, or minus x squared. Now, I don't know if you're paying attention to this. The denominator has a 9, it's got an x, and it's got an x minus 9. Okay? They decided to play a dirty trick on you. So, we're going to fix it. We're going to take care of their dirty little trick. We factored out a -1 right here. We factored out a -1, which causes the top to flip to x squared minus 81, which is more commonly what you've seen before. So that top can be factored into x minus 9 and x plus 9. Okay? And the two factors that will cancel out are x minus 9s. Leaving us -1 times x plus 9. Now, what I saw on the answer sheet, they might accept this answer right here. Oops, sorry. They might accept this answer right here, but what I saw on the answer sheet was they put the negative in front. They put the x plus what? Wait just a doggone second. We got rid of the x minus 9 from the bottom. The x plus 9 would be in the top, but the only thing left in the bottom was a 9x. What the heck am I putting all that crap over there for? Here, let's rewrite this just for kicks and giggles. But the key thing I'm trying to tell you is they put the negative out in front. I don't know why we have that there. So I don't know if they'll have a problem if you put it in the top with parentheses. They shouldn't even have a problem if you distribute it to the top. I mean, that's the same thing right there. You know, all you're doing is looking at distributing it. But, you know, you can see which one they take or which one they accept. Any one of those. It would be a lot easier if you're, you know, actually in a classroom with me, because then I could accept them all. Okay, question 13 here. Let's zoom in on this. Did we have restrictions on that last one? No, we did not. Okay. Okay, so first thing I did was I factored the denominator. I got x minus 3x plus 1, x minus 3x minus 1. Okay. Then I asked myself, what's the first denominator missing that the other one has? Obviously, the answer is x minus 1. Right, so top and bottom, I multiplied by x minus 1. The other one's missing an x plus 1, so I multiplied it by top and bottom. So now the denominators are the same. They all have an x minus 3, an x minus 1, and an x plus 1. So how do I get all the numerator stuff together? Well, time to distribute. 5x squared minus 5x. Now, keep in mind, this negative goes with the 7x. Lots of kids forget that, and then they make mistakes. So, minus 7x squared minus 7x. Then we can start putting things together. For instance, 5x squared and negative 7x squared is negative 2x squared. Negative 5x minus 7x is negative 12x. Okay? Now, I would take a look at this and go, okay, what's the GCF? Because Math Excel actually wants you to pull that GCF out in case there's a factor that will cancel with something in the bottom. They actually want me to write my answer like this. Nothing did cancel out, by the way, but I can leave my answer like that. The factors, my restrictions are 3, 1, and negative 1. 3, 1, and negative 1 for the restrictions here. You set those factors equal to 0 or not equal to 0 and solve them. Okie dokie. So it looks like on number 14 here, the first fraction is missing both a 7 and an x, so I multiplied top and bottom by 7x, which gave me 49x plus 4 on the top and 7x squared on the bottom. That's it. I can't do much. I can't do anything more with that. That's totally it. There's no way to reduce it or anything. Okay, 15. I know this has been a long video. We got a couple more to do here. So the first fraction was missing an x plus 2, top and bottom. The second fraction was missing an x minus 3, top and bottom. Then, of course, I'm distributing the 4 and the 5. And then adding like terms, right? 4x plus 5x, that's 9x. 8 minus 15 is negative 7. And there's nothing that cancels with anything in the bottom. So, done with that question. 16, I think this is it. Yeah, okay. So, the x minus 3x plus 2 is the factor there. X minus 5, x minus 3 is the factor there. The first one was missing an x minus 5, so you can see I multiplied that top and bottom. The second one was missing an x plus 2, top and bottom. And then I distributed 5x squared minus 25x, 6x plus 12. And let's see here, you can add those together and give you negative 19x. So we got the 5x squared minus 19x plus 12. We got to factor it to check to see if we can reduce this. Remember, check for GCF before we do the Berry method. So you can see that we are going to multiply the 5 and the 12 and get positive 60. Then we're going to factor this x minus 15, x minus 4. Then the 5 comes back into both of the x's, and we look for something that has a greatest common factor. You can see the first one here has a greatest common factor of 5, so we can pull that out. That would be, and remember, we're getting rid of it. We're not keeping it. So x minus 3 would be your first one when you pull out the 3, or the 5. The second one doesn't have anything that you can pull out, so it's just 5x minus 4. And the bottom is just your all your factors. Now, we can look for ways to cancel. Like, for instance, we can cancel those two. And that's going to leave me with 5x minus 4 on the top. And x minus 5 times x plus 2 on the bottom. I don't think they ask about restrictions there either. Okay, you're ready for the last assignment and then move on to the test. If you need any help, you know where to reach out to me and get online with me after school on Thursday. Sounds good? I hope if you need help, you'll take advantage of it. And there's always that retake in case you don't like the score you got the first time on Friday. All right, talk to you later. Bye.